This is the audio notes on characteristics of acids and bases. Again, I'm just going to put out all the bullet points for this first slide. What I want you to understand is usually with these characteristics, these are not things that I'm going to ask you on a test, like do acids give things sour taste? No, but we want you to know a little bit about what we're talking about. You find acids in a lot of fruits, for example, and that can give it its sour taste. So that's one characteristic of it. Acids are good at conducting electricity. If you've ever heard the term battery acid, your car, for example, has battery acid. Sulfuric acid is the electrolyte solution. When we talk about state of matter, acids are usually found as a gas or a liquid. Now we can make them in a solution form. There are some weak acids that are solids and then dissolved as well. One of the things that you've already seen this year, whether or not you knew it, is in those little film canisters you reacted metal with acid and it made hydrogen gas. Remember when you lit the splint on fire and you put that splint right over that little film canister and made that popping sound? That was from the creation of hydrogen gas. The reason why acids create hydrogen gas when reacting with metals is, well, it's a single displacement reaction, so the metal is going to be more reactive than the hydrogen for it to occur. But remember that acids, hopefully you got this from the reading guide, have hydrogen. Lastly, I want to make sure that you know that this is not a definition of what makes something an acid. Instead, it's a general characteristic. At room temperature, things below 7 on the pH scale are acidic. Now, again, I can't say this is a definition because this value of 7 is temperature dependent. And quite frankly, the information we give you for pH in Chem 1 will be expanded upon in future chemistry courses, but the next set of notes will be specifically on pH as well. Instead, if I were to ask you, what makes something an acid? Again, we cannot answer pH below 7 for reasons that go beyond what you need to know right now. Those two reasons, I believe, are addressed on the reading guide. Anything that creates the H3O plus ion in solution. That H3O plus ion is called the hydronium ion. The second definition is anything that donates an H plus. H plus is often referred to as a proton, because if you think of a hydrogen atom and you take away an electron, it now has a positive charge. You've taken away an electron from a hydrogen atom, all that's left is a proton in its nucleus. What I'd like to do then is show you an example of this on the smartboard. Very common acid that we're going to be going over that you've used before is hydrochloric acid. One definition of what makes something acid is if it's dissolved in water, it creates hydronium. Well, if I put hydrochloric acid in water, what happens is this hydrogen here gets attracted to the partial negative end of oxygen, so much so that it actually bonds to it. It creates H3O plus. The leftover would be the chloride anion at that point. So HCl has a hydrogen, so for recognition, hey, it has a hydrogen, although we can't define it as anything with a hydrogen because there's a lot of things with hydrogens that aren't acid. But what happens is it gives an H plus to water. The two definitions of an acid that you need to be aware of is one, in the presence of water, does it create hydronium? That's that H3O plus ion right there. Second definition is, does it donate an H plus? In this case, yes, it does. There are several acids that we work with in chemistry. We ask that students know the name and formula of these four. Now, there are naming rules for acids that we could go over, but instead of going over 3 naming rules, we decided that you should just memorize 4 acids. Those acids are sulfuric acid, H2SO4. You're going to be working with that in the neutralization lab coming up on either April 27th or April 30th. Hydrochloric acid, HCl. You'll be working with that next class and during the titration lab. It's the most common acid used within chemistry laboratories. Nitric acid, HNO3. This will be used during the semester project a fair amount. And lastly, acetic acid, HC2H3O2. Acetic acid is commonly found in chemistry classrooms because it's used for spill cleanup. If you spill a base, which we'll talk about bases in a little bit here, acetic acid is often poured on it to help neutralize that acid to make it safe. Acetic acid is the main ingredient in vinegar. So you might see jugs of vinegar laying around a chemistry classroom to help keep them safe from spills. So once again, hopefully you wrote down these 4 formulas, and we're going to start practicing them in a little bit when we go over how to write neutralization reactions. But you do need to know those formulas. Last thing that I've mentioned that you don't have to write down in your notes is what do they all have in common? They all start with a hydrogen. Now notice in acetic acid there's hydrogens in the middle. The reason why it's not called H4C2O2 is because only this hydrogen here can be donated. Again, that gets into the structure of the molecule, which is beyond what you need to know as a Chem 1 student. So for the most part, as a Chem 1 student, you're looking, does it start with hydrogen? If so, it's an acid. Let's talk about bases. Okay, now I'll put down a few characteristics of bases. Bases are usually found in the solid form, but we can dissolve them in water to make an aqueous solution. Bases are often slippery to the touch. A lot of cleaning products you get on your hand, your finger, and your thumb can kind of glide between the two. Again, kind of movie trivia here. I'm not too concerned if you actually know this third bullet point, but if you've ever seen the movie Fight Club from the 80s, besides it being a movie about people that kind of beat each other up in basements for fun, the main job of the main character is to sell soap to hotels, and he does it by taking a base and reacting it with oil, and that base actually comes up in the movie a few other times as well. Bases are often found in batteries as well. They also conduct electricity. When I talk about acids and bases being able to conduct electricity, a solution that has ions can conduct electricity. So it can even be things that aren't acids and bases. It's just one of the properties that are often brought up dealing with bases. And once again, the last bullet point, some of you are familiar with what's called the pH scale, pH standing for power of hydrogen, because acids give hydrogen. Above 7 on the pH scale is going to be something that is a base. And again, there's a lot of math involved with the pH scale that I don't need to get into. And one last thing I'd like to remind you is that we will not define a base as something with a pH above 7, because that's only technically true at 25 degrees Celsius, and we don't want to get into all of the explanation behind that. Instead, there are 2 definitions that I would like you to be aware of what makes something a base. The first is anything that increases the hydroxide, the OH minus concentration in solution. Hopefully OH minus looks familiar to you. That is a polyatomic ion, hydroxide. The second thing is anything that can accept a proton. Notice how that's kind of the exact opposite of an acid definition of donating a proton. Once again, I'm going to go back to the Smart Notebook now to kind of give you an example. Feel free to pause this video here if you need to finish writing down the notes for this slide. A very common household base is ammonia, NH3. When ammonia is put in the presence of water, what's going to happen is water is going to have a hydrogen be attracted to the NH3. So it's going to accept an H plus to make NH4 plus, and if water loses an H plus, it becomes hydroxide. Some of you might be looking at this equation or open the board and wonder what's going on with this weird arrow that I showed that's going in both directions. I'm trying to write down a correct explanation of what's going on with ammonia in water, and it deals with something called equilibrium, a topic that we will be covering in about 2 weeks. So I'm going to leave that portion for a later time for you to understand. So again, what makes ammonia a base? It creates hydroxide when in solution. Well, what do you mean by solution? I mean, I took a solute and I put it in water. Second definition of what makes ammonia a base, it accepts an H+. And if we move on to my last slide, the nice thing about bases is they usually go by ionic naming. Sodium hydroxide is far and away the most common base used within a laboratory. You'll be using it in both lab activities coming up later this week. Calcium hydroxide, calcium carbonate. Another one I could have added on here is sodium bicarbonate. If you ever notice, a lot of chemistry classrooms have a box of baking soda because if you spill an acid, you can add sodium bicarbonate to it. That is a base that can help neutralize an acid. Ammonia is a very common household base as well. And the last question I have that you don't have to write down is, what do you notice the first two having in common? Hydroxide. Again, the best giveaway of what makes something a base is, does it end in an OH? Again, it could get a little trickier than that, but that is a pretty good indicator of it. The notes for properties of acids and bases are done. What you're going to do next is go over acid-base reactions. After all, this is the advanced reaction unit. So what happens when HCl is mixed with NaOH, or HCl is mixed with CaCO3, or H2SO4 is mixed with NaOH? That is what your teacher will go over now.